Let's start then with the next session, which is going to be devoted to the stream-oriented generic enabler, Kurento. If you were here yesterday, you can remember that we made an introduction about this unique enabler, and we stopped creating our very first application, which was basically something that we called Hello World, which consisted on using a web browser, WebRTC capable for catching the stream from my webcam, sending it to the media server, and having the media server give back to me the stream. We were reviewing a little bit this application, and basically, if you remember, we needed to create a very simple pipeline. Allow me to remind you that the pipeline is a chain of multimedia capabilities in the context of Kurento. So that we define a pipeline which is going to contain a chain of multimedia capabilities. And in this case, given that we don't want any kind of processing, we just need the capability of sending and receiving WebRTC streams. And the media element that is capable of doing that was the WebRTC endpoint. So in my pipeline, I just need to instantiate one WebRTC endpoint, and I just need to connect this WebRTC endpoint to itself, so that its source is connected to its sink. And after that, I just need to complete the negotiation with the browser. I just need to complete the negotiation with the browser, and this is done, if you remember, through the exchange of some strings that were called SDPs, Session Description Protocols. So that at the browser I need to generate the SDP with the offer, and at the media server I negotiate that offer and I generate an answer. And I need to provide the answer to the browser. So this was the philosophy of this first application. And the architecture was this one. In the application, you just need to consume a couple of APIs, the Kurento client API. Through the Kurento client API, we are going to create the pipeline and to create the WebRTC endpoint. And through the Kurento utils, we are going to control the WebRTC capabilities of the browser. Okay, so this is just a reminder. We made a demo about this, and today we are going to learn a little bit more about how to create applications for the real world with Kurento, and we are going to show many different capabilities provided by the media server. So the first thing you need to realize is that the Hello World application we created is making the media server to communicate directly with the browser. So I come back to this slide, and this is the architecture, so that the browser is speaking directly with the media server. This is good because it is simple, but for real world applications, this is not very appropriate, because the media server is not providing any kind of security so that anyone could be able to connect to it. And this is the same that happens when you create web applications, for example. Web applications, you could make a browser to speak directly to a database, but nobody do that. Why? Because it will generate a lot of security problems. So in the context of the web, people always work with a three-level architecture: the browser, an application server, and the application server contains the logic, the web logic, and contains also the logic for connecting to the database, and a service level where the database is located, so that the database only communicates with the application server. For creating real-world applications with Kurento, you need to use this same three-tier architecture, so that the browser is not going to speak directly with the media server, but it is going to speak with an application server. We are providing off-the-shelf Kurento client APIs for Java and for JavaScript, so that you can use any Java compatible application server or any JavaScript compatible application server, including Node.js. And in this case, the application is the same. We are just making a loopback so that the media which is generated by the browser is sent to the media server. But instead of having the browser communicating directly with the media server, the browser communicates with an application server. And this application server can provide the authentication mechanisms you want or wherever you want, okay? And once the application server has made the appropriate authentications or has executed appropriate logic, you can just put the code creating the media pipeline and managing the different media elements at the application server. And in that case, the only issue is that you need some kind of mechanism for transporting the SDP offer from the browser to the application server and the SDP answer from the application server to the browser. In other words, you need some kind of communication mechanism between the browser and the application server, which can be a WebSocket, can be REST, can be sock.io or wherever you want. Okay, but you need to provide that type of communication between the application server and the browser. So if you want to see the code of this application, it is exactly the same that we showed yesterday. But if you have the curiosity, you can find it over there. It is exactly the same, but it is executing at the application server instead of executing at the browser. Okay. So basically, the call flow in this case is the one shown in this picture. The letters are very small. You probably don't have the possibility of reading them, but it is not important. The important thing is that the browser, which is in pink, just need to say, okay, I want to make a communication with you, and this is my SDP. And then the application server has a dialog with the media server using the Kurento client API. Okay, and as a result of this dialog, an SDP answer is generated, and the application server just needs to provide the SDP answer to the browser. So between the browser and the application server, you just need to message. One message saying, I want to make a call, and this is my SDP, and the answer which says, okay, this is the answer, the SDP answer for you. Okay, that's all the communication you need. And using this architecture, of course, at the application server, you can provide the security you want. You can connect to any kind of databases. If you are using, for example, Java compatible application server, then you can use all the capabilities of the Java enterprise platform. So over there you have enterprise service buses, connectors to all kinds of databases, whatever you want. Okay. Okay, so given that we understand that this is the appropriate architecture for your application, we are going to start creating more interesting applications, making more interesting things. One of the things that a lot of people want to do when working with multimedia is having the capability of recording multimedia, of recording media streams in the file system or in a database, and of recovering those streams for playing them whenever you want. Okay. So if you think about this, and if you think about our philosophy, the philosophy of Kurento, which is based on having media elements, this means modules providing a specific capability and connecting those modules. Okay. So if I want to record a WebRTC stream, what I'm going to need? I'm going to need one module capable of receiving the WebRTC stream at the media server, and another module for recording the media stream, and I just need to connect them. So at the top of this slide, you can see the pipeline for that application, for an application recording whatever it is receiving from the browser. So the media server receives the stream from the browser and records it into the file system, for example. Okay. if I want to reproduce later in the browser that file, I just need something capable of playing files, of getting the files from the database and from the file system, and giving that to a WebRTC endpoint, which is the guy who knows how to send the stream to a WebRTC capable browser. Okay? So basically, an application for recording and playing just needs to incorporate these elements. What is going to be the shape of this application? I'm going to create a media pipeline. I'm going to create a WebRTC endpoint. I'm going to create, when I want to record, I'm going to create a recording endpoint, and I'm going to connect both of them. And once I have connected both of them, I just need to make the SDP negotiation. This is always the same. The browser generates the SDP, I give the SDP to the WebRTC endpoint, and the WebRTC endpoint generates an answer. And that answer is sent back to the browser. That's all. That process is a little bit obscure, as I told you yesterday, but it is always the same. The browser generates the offer, I give the offer to the WebRTC endpoint, the WebRTC endpoint generates the answer, I give the answer to the browser. Always the same in all situations, okay? So once we understand that obscure part, the rest is very easy. I just need to connect to the recorded endpoint. So if you want to take a look to the code of this application, this is the URL for it, okay? There are different ways of implementing this application. You can do it in JavaScript, you can do it in Java, and in JavaScript, we also have support for generators and promises. How many among you know what is a promise, a JavaScript promise or a JavaScript generator? How many among you? Okay. So when you program with JavaScript, you know that there is a problem called the callback hell. The callback hell is that I need all the time to be programming in callbacks. This is due to the fact that JavaScript is an asynchronous language. So in ECMAScript 6, in Harmony, they are introducing something which makes possible to use a synchronous philosophy for developing with JavaScript, so that I can just put the different commands I want, and the language behaves as if the call was synchronous, was blocking. Okay. So in this example, I am showing you that code with generators. So that using generators, you have, as I told you before, the advantage of avoiding the callback hell. We can make a simple demo of this if you want to see it working. So here, I hope you see it like this. Yeah. So here, basically, the project contains a directory with the JavaScript code, an HTML file, and dependencies are somehow managed using FIWARE, so that you just need to make FIWARE install, and all dependencies are automatically downloaded to the directory where you're working. Okay. So here, I can see the web page. Basically, this is a very simple application, which is implementing this pipeline as we have just explained it. We are going to record and we are going to play. So for recording, I just need to press this button, and I press it. It asks me for sharing my webcam. I allow the browser to access my webcam, and then the browser just is catching my image, and everything right now is being recorded. Okay. So if I stop, I have right now the clip recorded into the file system, and the recorded endpoint, which is the capability we are using for recording, makes possible to write the file into any kind of URL. You can provide a file URL, and in that case it is writing in the local file system, but you can also provide an HTTP URL, and in that case you are sending the media using HTTP put, a put request. Okay, so you can integrate with any kind of repository capable of providing put. And now if I press the play button over here, I see the clip which was recorded previously. Okay, so this is a very simple example, and if you want to take a look to the code, all the code is available in GitHub in the Kurento web repository. Tutorial. So this is specifically the project where we are implementing the recorder, and here we have the code implementing the application, so that this is, for example, the playing part, and this has been programmed using generators, as I told you before. So basically I say create the media pipeline, and I get the media pipeline, and if you see, there are no callbacks. It is like if the call was synchronous. And in the line before, given that it is behaving as if the call was synchronous, I have the pipeline, and I can ask to create the WebRTC endpoint, and I have the WebRTC endpoint. And now I ask to create a player endpoint for playing this file. Okay, this is the playing part of the application. And the generators require this yield, which is some kind of magic word for avoiding the callbacks. Okay, and the recording part is this one. I just create the media pipeline, I create the WebRTC endpoint, and I create the recorder endpoint. I need to connect the source of the WebRTC endpoint to the recorder, and I connect the WebRTC endpoint to itself for making a loopback, so that I see myself in the application. Okay, and then I just ask the recorder to start recording. I say, recorder, start recording, and that's all. Of course, I need to make the negotiation. This is always the same. Okay, this is the offer generated by the browser, and this is the answer generated by the WebRTC endpoint using generators. And here I'm asking the browser to process that answer, so that the video can start its change. Okay, so this is our recording and playing example. And now we are going to start making more complex things, such as, for example, making communications. Making communications means communicating to different browsers, so that my browser can communicate with your browser if both of us are connected to the internet. Okay. And in the case of the communications, if you just in the case of multimedia communications, you just need point-to-point communications between two browsers. You don't need Kurento at all. If you don't want to process the stream, you just need to communicate from one browser to other browser. WebRTC provides that off the shelf. But if you want to make group communications, you have two options. One option is to use directly WebRTC as it is provided, and in that case you need to make a mesh topology, meaning that if in my group there are 4 people, I need to send 4 different streams to every one of the participants from my browser, and this is going to consume a lot of bandwidth. Okay, so that most people prefer to use topology based on a middleware, and this middleware is a media server, so you can use Kurento for creating that type of topologies. So we are going to start working with this kind of topologies where a browser sends the media to the media server, and the media server can distribute to a number of other browsers. And we are going to start doing this with a very simple application, which is basically what we call the one-to-many. One-to-many means that one browser is producing media and many browsers are consuming media, so that I can be somehow generating a media stream from my webcam and you could be consuming that media stream from your laptops. So this application is simplex. The media is from me to you. It is not full duplex. Later we are going to work with full duplex applications where the communication is bidirectional. But this specific example is only one direction. Okay? So basically the idea for implementing one-to-many applications is that I need one WebRTC endpoint for receiving the stream. This is the WebRTC endpoint on the left. And as many WebRTC endpoints for sending streams viewers are in the system. And given that I can connect the media elements in the way I want, the Kurento API does not restrict how I connect media elements. I can connect the source of the media element on the left to as many sinks on the right as I want. You can see the idea, isn't it? So that for adding a new viewer, in my code, I just need to instantiate a new WebRTC endpoint and connect to the presenter WebRTC endpoint, the master WebRTC endpoint, which is the one depicted on the left. Okay? Of course, I didn't tell you, but you can interrupt me at any time if you have any questions. If I am speaking about something and you have an interest in knowing more or you have any questions, I don't have any problem if you interrupt me at any time. So the code for this is here. You can also find it in the GitHub, Kurento repo. And basically the call flow is depicted here. Again, there are a lot of lines over there, but the interesting part is that in this application, there are two types of users. The master user, who is going to provide the master web RTC stream, and the rest of users, which are viewers. So the first thing that needs to happen in this application is that the master connects. So in this application, I need the master connecting. The code in my application is going to create a WebRTC endpoint for the master. This is everything that it is going to do. Of course, for that WebRTC endpoint, I need to make the negotiation of the SDP with the master. Again, the master generates the SDP. I give that SDP to the WebRTC endpoint, and the WebRTC endpoint generates the answer, which is given back to the master. So this is what is going to happen. And after that, I can have viewers connecting, as many as I want. And for every viewer, I'm going to create a WebRTC endpoint. I'm going to negotiate the SDP with the browser of the viewer, and I'm going to connect the sync of that WebRTC of the viewer with the source of the WebRTC endpoint of the master. Do you see the idea? So basically, we come back to the pipeline. The first is creating what we can see on the left. And in a second stage, we are going to create the endpoints on the right one by one. Every time a viewer is connected, we create one of these endpoints and we connect with the master. This is the idea. So again, we can show you a demo for this. And in this case, for example, this is, I'm going to show you the Java demo. We have also JavaScript demo for Node.js. These demos require an application server. Okay. So if you take a look, the Java project is has been somehow prepared for work with Maven. So you just need to make Maven compile, Maven package, Maven install. Sorry. And for executing it, I can also use Maven. I'm going to ask Maven to start this application, and I need to provide a Java property showing where is the media server. The media server is in my own laptop, but in a different IP associated to a virtual machine I have on my laptop. Okay. So when I start, I need to tell the application the media server is here, so that the Kurento client can find it. So we start the application, and everything's ready now. And the application, as I told you before, starts by creating the master endpoint. So I press in master, and here the master is negotiating with the WebRTC endpoint, and right now we have the master. Okay, so the master is sending the media to the media server, but right now the media server is not doing anything with the media. For the media server doing something, we need to add a viewer. So in another tab on my browser, I'm going to add a viewer. So I press into viewer, and right now the viewer is negotiating with the media server the SDP. The media server creates a WebRTC endpoint, and it connects with the master. So right now I have the master sending the stream to one viewer. Okay, and here this video stream is coming from the master, which in this case is my laptop. But if you connect to this application from your laptop, you will see my webcam. Okay, and again here I can add further viewers if I want. So if I press here, I can add one additional viewer, and I can be adding viewers until the scalability of the media server, which is around a couple of hundred of viewers. Okay, but if you need more, you can change different media servers. So right now you have 2 viewers, and we could be adding here viewers. And one advantage of this is that, given that we are using WebRTC, the latency is very small. The latency is sub-second. If you try to make a live broadcasting using other types of technologies, using, for example, Google Hangouts Live, or using technologies such as Voice and Media Server, you will see that the latency is of several seconds, 10, 20, 30 seconds. Okay? In this case, the latency is very, very small, sub-second, because WebRTC is prepared for this. So this is quite interesting for applications where you want to make a broadcasting with very, very low latency, sub-second latency. Okay, so I stop this viewer, and here I stop the master. This is the master, and the other viewer has stopped automatically, because of course if I stop the master, the viewer cannot continue to see anything. So this is basically the idea of this application. If you want to see the code is a little bit more convoluted in this case. I can show you later in the lab sessions, but it is in essence it is quite simple. It is just creating the different WebRTC endpoints and connecting them. That's all, in the way I want. So now we are going to work with full duplex communications. Instead of just making the media to flow from me to you, we are going to create applications making possible to make a video conference, basically. Okay. So for making a video conference, basically I'm going to need a couple of WebRTC endpoints connected to each other, so that the source of the first is connected to the sink of the second, and the source of the second is connected to the source of the sink of the first. Sorry. So this is basically what you can see in this picture. So we are going to show right now an example doing this, and in this example, the example is basically a phone-like application. Phone-like application means that this is an application making it possible to make video conferencing calls, so that I can call the other party. So this application requires a first step, which is the registration, so that the users that can be reached through the application need to be registered into some kind of repository or database. So if I want people to be able to call me, I first need to connect to the system and say, okay, I am here and I am ready for receiving calls from the system. And everyone who wishes to receive calls needs to be somehow registered. And once people is registered, I can make a call to anyone who is registered. And for making a call, I just need to notify that I want to make a call to the other party. This requires some signaling. But from the perspective of the media server, we just need to create the two WebRTC endpoints and connect them to each other so that the string can flow in both directions. So with this, we will have basically transport between the two parties, between the people in the video conference. But this is something you can do with any other technology. So for doing this more interesting, we are going to make a little bit more complex the pipeline, so that you start thinking about a Kurento developer. Given that everything works with models, I can make some processing, if I want, in the middle of the communication, so that in the middle of the two WebRTC endpoints, I can make the processing I want. Just as an example, I'm going to create an application. I'm going to show you it right now. Putting a face detection media element in the middle of the communication, so that the system is going to detect the presence of faces. And we are going to be able to do things with faces. We can take a picture of the face, or we can use the face for putting things related to the face, because we have the coordinates of the face in the image. We have the coordinates of the face, we have the coordinates of the eyes, we have the coordinates of the mouth, of the ears. So we can add logic to the system depending on the position of the face, on the size of the face, things like that, okay? And at the same time, I want to record these streams. So I just need to add a recorded endpoint. So see how I have transformed this, which is just making transport, into this, which is putting things in the middle of the transport. Do you see the idea, isn't it? So basically, if we come here, we can also start this application. Again, this is a Java application working with Maven. And again, I can start it. And if I come here, I have the application, and the application asks me first to register, because for receiving calls, I need to register. So imagine I am a user called Alice, and I register. Okay, so Alice is registered. So anyone can make a call to this browser right now. And in another tab, we're going to create a tab here. I can register another user. Imagine here in this other browser we have Bob. So we have right now Bob and Alice registered. Okay, we could register additional users if we want, of course. And imagine right now that Bob wants to dial Alice, want to make a call to Alice. So I just need to put here the name of the person, the name that that person used for registering, of course. So given that Alice registered using the name Alice, I put Alice here, and I made the call. The browser asked me for sharing the webcam, and now if I go to the tab of Alice, which is this one, Alice receives the call, and in this case, the call somehow is a signal that is received in the browser, and we are opening a window alert for it. But you could do whatever you want. Okay, you could make a sound to reproduce or whatever. So Alice receives the call. Alice needs to provide access to the webcam, and right now the connection is established. Right now the two endpoints are negotiating the SDPs, so that we are creating two WebRTC endpoints. And as you can see, there is a face detection algorithm who is detecting my face, and in this case, I'm using that information for putting a hat on top of my head, so that Alice sees Bob's with that hat of Mario, and Bob sees Alice with the hat of Wizard. Okay.
Why is the hat so bumpy, so flickering?
Sorry?
The hat is so flickering inside.
Yeah, because the algorithm you can create somehow smoothing algorithms. This is just using the raw data provided by the face detector, and that raw data has some oscillations. Okay, and with the illumination we have here, more, because if you see, my face is somehow very dark. For this algorithm to work well, you need to have the face better illuminated. But in any case, you will always have that oscillation, and if you want to avoid that oscillation, you can make an average of the positions of detected by the raw filter. Okay, and if I stop, the call is stopped. And if you remember, in the pipeline we put that face detector in the middle, but we also put a recorder, so everything has been recorded. Right now, if I press here, I'm going to access the string of Alice. So this is the string received by Alice. Okay, and we can see that the hat has been recorded. And to check if you understand how Kurento works, I would like to ask among you, how do I need to modify the pipeline so that I just record the face but not the hat on top of the face? How can I modify the pipeline?
Change the recorder near the source.
Yeah, that's the point. Instead of connecting the recorder to the source of the face detector filter, I need to connect it to the source of the WebRTC endpoint. And in that case, I will be recording whatever the WebRTC endpoint is providing, which has not a hat, because the hat is being added by the filter in the middle. So this is the power of Kurento. The power of Kurento is that you can modify what your application is doing just by connecting in different ways your media elements. Okay? So, okay. So basically, after seeing this example, I hope you start understanding better this slide, which we presented yesterday. In this slide, we said that most multimedia communication technologies are in the philosophy we can see at the top, so that they just eliminate distance. But what we have created for FIWARE, the string-oriented generic enabler, and its implementation, which is Kurento, is doing more by making possible to put things in the middle of the communication for making interesting things with the media. Okay? So right now we are going to see some interesting things I can do with the media. One of the things that I can do with the media is use augmented reality. So I don't know if you know what is augmented reality, but basically it's putting things on top of the reality shown by the media. Our previous example, the example of the hat, was augmented reality based on a face detector. But it is more typical for augmented reality to require to use some kind of markers or markerless capabilities. And if you are not familiar with augmented reality, you are going to understand it with this simple example. So in this case, I show you first the demo, and after that, I explain you the ideas, okay? Because it is going to be more simple. So in this demo, we just create a pipeline with a WebRTC endpoint, and we are connecting the WebRTC endpoint to an augmented reality capability using marker augmented reality. Okay. So in this case, I'm going to put in this direction because the illumination is better. Okay. In this case, in the left, you can see the image as it is captured by my webcam, and in the right, you can see the image processed by the media server. And they are the same, they are equal, okay? The point is that the media server is looking for some specific kind of markers, which are some kind of codes of shapes, let's say. And when the media server finds these shapes, it is capable of adding things on top of these shapes. So for showing you the effect, I've got here a t-shirt. Okay? This is a t-shirt with the marker. And if I show the t-shirt to the webcam, you can see that the marker is replaced by an image. I can select the image A1, of course. And in this case, given that this is a professional augmented reality filter, as you can see, the marker is not shaking as the hat. The hat, somehow it is just for making demos, but this is using a professional and commercial augmented reality capability. So as you can see, it is quite robust. And we have made several demos where we put the t-shirts ourselves. Okay, I'm not going to do it now because I think the effect is quite clear, but if I put the t-shirt myself, and if I show here, but then the logo is replaced, okay? So somehow this is what this specific application is doing. It is basically catching the stream, and it is applying the marker augmented reality filter. And right now, after the demo, you understand what is the marker augmented reality filter. It's an augmented reality filter based on a marker, on a specific shape that I need to put somewhere, okay? And you can think, and why this is interesting? This is interesting for several types of applications, but the main one is if you work in areas related to advertising. Advertising, it is still the main business model of the internet. You can make somehow video transmissions, putting different advertisements for different people, because you can replace the marker with different image for different people. So we can somehow modify our one-to-many application. We can modify it so that every receiver, every viewer receives a different advertisement on top of the marker, for example. So we are able to make live video broadcasting with segmented advertising with this type of filter. This is a possible use case. You can also replace the marker with other information you want. If you put the marker into this wall, for example, you can let a user to come to the marker, and instead of the marker, see the information you want. You can put, I don't know, in the morning, the menu of the restaurant, replacing the marker, and in the afternoon, you can put the schedule of the laboratories or whatever you want. So somehow this makes possible to create different types of applications, because in the Kurento API, the thing replacing the marker is just an image, and you can provide that image to the media element, and that image can come even from a web page. So you can have the image in any website you want, and you say the marker replace the marker with this image. And of course, given that you are programming that logic, you can make that replacement to depend on the hour of the day, on the geolocation of the person, on whatever you want, on whatever information you have available. Okay? So this is a beautiful use case of Kurento. Another use case is for security. For example, we have a filter detecting motion so that you can have a camera and you can select on top of the camera the regions where you want to detect motion, so that when motion is detected, an alarm is generated. We are a little bit short of time and I cannot show you this demo. I prefer to go to this one, which is the last one, which is an application we created specifically for FIWARE related to smart cities. And this is using a filter called crowd detector. A crowd detector, as its name indicates, is capable of detecting crowds of people in the streets. So you can basically create a pipeline connecting to a street camera. We support to connect to any kind of RTSP capable camera. And we can somehow give the string of that camera to something detecting crowds. And when a big crowd is detected, we send a message to the Orion context broker, for example. You already know what is Orion context broker. So that, for example, policemen can receive a message saying there is a crowd in that street, and policemen can connect from any browser having WebRTC capabilities to see in real time the webcam, the IP camera, sorry. So I would like to, before concluding, to show you this demo, which is quite beautiful. And again, this demo is based in Java. The code is again freely open for you in the Kurento GitHub repository if you want to take a look to it. So we are doing it with a recorded file, okay? Because given that we don't know if we are going to have good connectivity in this type of demos, we recorded a file. But this is a square in Madrid. Do you know which is this square? It is Puerta del Sol. It was recorded during Christmas, okay? And then we have a camera pointing to Puerta del Sol. And as you can see, there are little spots over there in red color and in blue color. These are the crowds detected. Blue means that there are people moving very slowly, and red means that there are people who has stopped completely, okay? So right now, the spots are very, very small, but if you imagine that in the middle of the square, there is, for example, somebody having a heart attack, very fast, a group of people comes to see what's happening, and then you have a crowd. And the system is detecting that crowd. It is elevating an alarm to the Orion context broker, and then you can subscribe to that alarm and open this application and connect to the stream and see what's happened, so that the policeman can not only know that a crowd is forming in Sol, but also can visualize in real time what's happening in that crowd, okay? So this is everything I wanted to show you. Thank you very much for your attention, and of course we are available for you during the afternoon for providing you the additional information you want or helping you with the installation of Kurento. Just one last word. Yesterday we detected that the Wi-Fi and the internet connectivity here is breaking the WebRTC traffic, okay? So if you want to have these demos working, my recommendation is that you install a virtual box into your laptop and you install Kurento Media Server on that virtual box. I can help you this afternoon if you want, okay? But you will not be able to execute these demos against the FIWARE lab, because the Wi-Fi is not allowing WebRTC traffic. It is for security reasons, I imagine. I don't know, but I imagine it is for security reasons that all UDP traffic is being filtered. Okay, so thank you very much. Text recognition, OCR. No, we don't have it, but if you don't have it, we can integrate it into Kurento very easily. And there are open source OCRs that could be integrated into Kurento easily. But we are not providing off-the-shelf an OCR. Okay? But it shouldn't be too complex to create, to integrate one, not to create, because there are a lot of them which are open source. Okay? Any other question? Yep.
You said that the augmented reality plugin or component is a commercial one.
It is a professional one who has been created by a research center in Finland called VTT, and its name is Alvar, but it is open source. Yeah.
No licensing costs.
No licensing codes. These people is making money through different ways, and that specific capability is open source. But it is commercial in the sense that they are giving services on top of that. Okay, but they are not selling licenses for that specific code. They are selling licenses for add-ons on top of that. Okay. Any other question? So thank you very much, and we let the next speaker to come.